Hey guys, it's Mrs. Olt again, and welcome to our video lecture on climate change, greenhouse gases, part 1. Hopefully you have your notes ready to go, whether you have maybe you're dual screening it, you have a printer at home and you printed them, however, but you have those in front of you ready to follow. As always, don't forget, if I'm going too fast, pause me, rewind me, whatever you got to do, just maybe don't fast forward me because you kind of have to get the information, right guys? All right, I hope all is well. Let's get started. So today's objective is to describe the greenhouse effect that occurs on our planet and to explain what greenhouse gases are and what they do. All right, so the greenhouse effect. The greenhouse effect is the natural warming of the Earth's surface and lower atmosphere. So this is something that happens naturally thanks to the composition or the makeup of our Earth's atmosphere. And what happens is that our atmosphere acts like a greenhouse and it warms our Earth's surface. This is caused by the sun's radiation, so light from the sun being absorbed by our atmosphere and emitted by the atmosphere. So we'll talk about a little bit more that not all the sunlight that comes to the Earth actually reaches our surface. Heat is absorbed by greenhouse gases. We've mentioned this many times already, that the makeup or the composition of the gases like CO2, water vapor, oxygen, nitrogen, a lot of those actually absorb heat and trap it close to the Earth's surface. And it's called greenhouse gas because they act as a greenhouse. Most of you are probably very familiar with a greenhouse. Greenhouses are made of material that trap heat inside so that you can grow plants indoors. And so it provides the heat and light that plants need in order to grow, maybe during conditions that wouldn't be so good like winter. And so just like a greenhouse absorbs solar energy, so does our atmosphere and the greenhouse gases in the atmosphere. So here's a picture that shows you what type of radiation is actually making it to the Earth. So we have our sun. We've spent a lot of time talking about the sun, and we talked about how the sun gives us sunlight. Well, first of all, not 100% of sunlight actually reaches to the Earth's surface. In fact, as you can see here, a lot of it, some of it actually gets reflected off. So a lot of it just immediately gets reflected by the Earth in the atmosphere. So immediately bounces back out into space. However, most of it does get absorbed by the Earth's surface and warms it, which is why you guys have all experienced if you go outside in July and it's 90 degrees outside and you step on your sidewalk with no shoes on, it's going to be hot because the Earth's surface is absorbing that sunlight. Some of the infrared radiation passes through the atmosphere, some's absorbed, we talked about that, and re-emitted in all different directions. In fact, some of the gas molecules, they kind of appear like golf balls. They have little bits of dimples around them on the gas and the molecules, and so it kind of scatters the light in all different directions. And the effect of this is to warm the Earth's surface and lower atmosphere. And then we know that the Earth's surface actually then releases a lot of that infrared radiation back at the end of the day. So it releases it back. So this is a cycle of we're absorbing, we're reflecting, we're re-emitting, and things like that. But overall, most of the energy does get trapped in our atmosphere, and a lot of it makes it to the Earth's surface, but it's not a 100% configuration. So let's talk about what gases actually make up the greenhouse gases. So remember, these are very important to Earth's climate and living on Earth because they trap energy from the sun. So sunlight enters the Earth's atmosphere and it actually has to pass through the greenhouse gases. The Earth's surface will absorb some of the solar energy. Some of it doesn't actually even make it into the Earth. A lot of it is going to be re-radiated back into space, and even some of it that actually makes the Earth's surface actually gets put back into our atmosphere. So at the end of the day, when the sun goes away, the heat that's been absorbed by the Earth releases back into our atmosphere. And as I mentioned, some of it never even makes it here. It immediately gets reflected back, and some of the heat from the Earth actually makes it back to space also. But the majority of it actually does remain trapped in our atmosphere by these greenhouse gases. And that's important. We need to have a warm earth in order to have life. So this results in the fact that the earth heats up and it keeps it at a relatively constant temperature that allows for life to sustain, keep things living on earth. So these are very important gases. So just remember, we've talked about this many times, greenhouse gases trap heat. So there are three major that we're going to talk about. The major greenhouse gases in our environment are carbon dioxide, water vapor, and methane. So all of these are extremely important. And if later you want to get into the PowerPoint and watch a video, you're welcome to do that. So these are the three main greenhouse gases. These all trap heat for us. So they are important because they maintain that comfortable temperature on Earth. Without these guys, you can't have life on Earth. Other planets are either way too hot or way too cold. And so these greenhouse gases are extremely important. But once again, this is about balance, guys. Too many of these greenhouse gases being released, the Earth will be too warm, and it's going to lead to changes that occur. And we'll talk about more of those later. Too few gases, and it causes the Earth to be too cold. And that's also problematic because then you have where things start to freeze in plants. So we need to have that balance, maintaining that equilibrium here. So a small change in global temperature, I'm not talking about day to day because we see changes. We can go from being 36 to being 65. We're looking at overall global temperatures. And the amount of energy it takes to change that is a lot. And having a small change in that can cause big problems. In this case, small change can be big problems, and we'll talk about those further. All right, so that is our introduction into what the greenhouse effect is and greenhouse gases. Now, don't forget, later today, I am holding a Zoom session. Remember, these are held on Tuesdays from 2 p.m. to 3 p.m. It's just to stop in and say hi, guys. It's not for us to talk and me to teach you. It's just for us to touch base. I just want to make sure you're alive and you're doing well and if there's anything I can do. So it's not a long time commitment for you. You should have an email on Tuesday in the morning with the link so that you can just click on it and join. And just stop in and say hi. Remember, you are required to attend 3 of these, so it's only about half of them. So if today doesn't work for you, perfect. Come see me next Tuesday, okay, guys? All right, and your other assignment is to complete the Greenhouse Effect Edpuzzle. So you need to click on the link to Edpuzzle on Canvas. Make sure you sign in. You guys are very familiar. We've done many Edpuzzles. Complete the Greenhouse Effect Edpuzzle one. So look at the list. There's about, I think, 4 or 5 of them I've assigned to you. So find the one that talks about the greenhouse effect. It's about 10 minutes long for you to watch. So not a lot going on today as far as assignments. Make sure that you complete that Edpuzzle by April 16th at 11 p.m. As always, guys, any questions, email, or remind me. And I will talk to you soon. Bye, guys.